Now in this video, I've got a 10-volt DC source. I've got a switch. Across my source, I've got a diode, and my diode is the 1N4007. I've got a 1500 microfarad capacitor, and between my diode and the capacitor, I've got a 10 millihenry inductor, and in parallel with my capacitor, I've got a 1K ohm resistor. Now my switch is opened, so now there is nothing going on in the circuit. So what I'm going to do now, I'm going to close my switch. I close my switch, and my current begins to flow. This side of my inductor is positive, and this side is negative. Now, there is no current flowing through my diode because my diode is reverse bias. This is my anode, and this is my cathode, and this is the positive side of the circuit. There's also no current flowing through my capacitor because my capacitor will block DC. Therefore, my current will be flowing through my resistor. The current is flowing through the inductor and through the resistor and back to my volt source. Now what I'm going to do is I'm going to find my output voltage. Now, in order to find my output voltage, I'm going to need my output current, and this will be the formula for finding the output current. Now what I'm going to do here is I'm going to find this symbol called tau. Find the value of it. And tau equals my inductance over my series resistance. That equals 10 millihenry over 1K ohm. Ten millihenry divided by 1K ohm. That equals 10 microseconds. All right, so my tau equals 10 microseconds. Okay. Now, I want to know what my time is I want to know what my current is at t equals 5 milliseconds, 5 microseconds. So what I do is I take 5 microseconds and I plug it in right here. So I'll go 10 milliamps times 1 minus e to the negative 5 microseconds divided by 10 microseconds. And that gives me a current of 3.93 milliamps. Okay? .93 milliamps. So my voltage is 3.93 milliamps multiplied by 1 k ohm. And my voltage equals 3.93 volts. Now, if my time was 7 microseconds, I go back to my formula and I change my 5 to a 7. Now my current equals 5.03 milliamps times 1 k ohm. Okay, 5.03 milliamps right here. Multiplied by 1 k ohm, that would give me 5.03 volts. So now we're at 5.03 volts and 5 milliamps, 5.03 milliamps. Now what I'm going to do is I'm going to open the switch. Now when I open the switch, there is no more current flowing through my 10-volt source. Now my current will be flowing through my inductor as the inductor discharges, and my inductor will discharge between my capacitor, my 1 k ohm resistor, and my diode. Now the polarity across my inductor changes. This side is positive and this side is negative. And my current will flow down through my resistor all the way to my diode, And my current will also flow down through my capacitor and through my diode. Now for a very, very brief moment, there will still be 5.03 volts across my resistor and a current of 5.03 milliamps. But as the inductor discharges, the voltage goes to zero, and the current goes to zero milliamps. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.